Hi, thank you for coming, and thank you for Zeiss and everyone for having me here. This is great. I get to talk about Pony, which I love, and also I get to be flown to Paris, where I'm going to have a nice vacation after this, so that's pretty awesome in my mind. My name is Sean T. Allen. The T is important. I've had jokes and other talks about that. If you want to understand, just Google my name, do an image search without the T, and you'll understand why I put the T in everything for professional stuff now. I am a member of the Pony core team. So yeah, I have to be careful with what I say. I'm also the VP of engineering at Sendence. We're a data processing company, startup in New York City, and we built a high-performance stream processing system in Pony. So everything I say in this comes from pain and experience. So Pony, what is it? Well, first of all, it's a programming language, and it's open source, object-oriented, actor model, capability secure, and it's high performance, which is an awful lot of buzzwords. The most important ones of those are probably the actor model one and the high performance, and that's mostly what I'm going to focus on today. Some key characteristics about Pony. One, it's type safe, and it's really, really type safe compared to a lot of languages. Yes, it does not have higher kinded types or other sorts of things. However, being an actor model language, and with some stuff we're going to talk about a little bit later on, reference capabilities, Pony integrates concurrency into the type system itself so that it makes it easy to write concurrent programs which the compiler can verify are safe, and we'll get into that more. It's also memory safe in the way that a lot of new languages are. No dangling pointers, no buffer overruns. If you're familiar with Rust, it would be similar to that. It's exception safe. There is a mechanism that looks like exceptions, although it is somewhat different. However, you cannot have any uncaught runtime exceptions. The compiler forces you to deal with them all. Some people, when they first come to the language, really hate that. After a little while, you get to really love it. It is data race free. This comes largely from the actor model itself, that you cannot have data races where, for example, you might have two separate threads updating data at the same time, or perhaps you have a lock. In order to try and protect it, you don't handle the locks correctly. Now you have deadlocks. With the actor model and with Pony, you don't get that, so it's both data race free and deadlock free. It compiles down to native code ahead of time, which is done using LLVM, and that ends up with a pretty fast language. Lastly, it is C compatible. The FFI is really easy to use, which means that one, it's nice for working with C libraries, which are not ones which, I don't know, require global variables and whatnot, but there's a wide variety of C code that's out there for you to use. This also means it's really easy to drop down into C and to violate pretty much all of the memory safety rules that you might otherwise get in Pony. So we use this every day in the product that we built with it. However, we also segfault things on a semi-regular basis when we first put stuff in that does that. So buyer beware on that. This is a general philosophy that goes into shaping Pony. This is the idea that a programming language in the end should be about helping you to solve hard problems, and that you can have different programming languages to help you solve different hard problems. Things like expressiveness and all of these other things that we talk about are nice, but in the end, if they're not solving the hard problems for you, then it doesn't really matter. It doesn't matter how expressive your language is if it makes it really hard in order to solve whatever your hard problems are. So, why might you want to use Pony? Well, to start with, you have a highly concurrent application or problem that you're trying to solve. Pony with the actor model is going to go ahead and it's going to make this really easy to do. Other couple things you might want to look at here are that you have an application where you're looking for predictable latencies, and last, an application where data safety is really important to you, and I'm going to hit on each of these as we go through this. So, highly concurrent. Highly concurrent application could be something like what we work on at Sendence, where the idea is that you can pipe tons of data in over TCP, over Kafka or whatnot, and we will fully utilize all of the cores which are on your machine or across the cluster of machines in order to process data as fast as possible. This is a high concurrency problem. Network servers, high concurrency problems, etc. So, what makes Pony good for highly concurrent applications? Well, one, there is the actor model of concurrency. I can't really see folks, but I sort of can. How many people are familiar with the actor model? Ooh, that's a nice number. Okay, so I'm going to do the short version of actor model, which is good because I have 15 minutes left. If you have a lot more questions about the actor model, find me afterwards. I love to talk about it and drone on endlessly. Basically, what you could sort of think of the actor model as is managed threads, where what you end up having is that each actor which you create in your system manages some sort of resource or data, and it will be run by a scheduler at some particular point in time. And the way that different actors communicate with one another is by sending messages, and then an actor performs actions by pulling those messages off of a queue and executing them one at a time in a serial fashion. This means that within an actor, it's very easy to reason about what's going on because everything is like you're writing a serial program at that point. An example of this could be something like you have an actor for handling incoming TCP connections. You have an actor for each individual connection which has come in, and they then go ahead and send messages off to some other actor which is responsible for, I don't know, parsing your JSON or whatever it is that you're doing, and then another actor for updating a database or whatnot. By using the actor model, you end up with not having to have any locks, deadlocks, etc. None of the problems you might have if you're trying to do your own managed thread system. Pardon me. Now, when a lot of people think actor model, they think something like Erlang, they think something like Akka. There are similarities between actor model systems, but in the end, there are also an awful lot of differences. So don't assume that, because Pony is an actor model language, it's the same as Erlang or Akka. There was somebody who asked me on Twitter before this, about 10 minutes ago, if Pony was another OTP Erlang ripoff, or if it actually had something interesting to it. I'll say this, there are a couple similarities with Erlang, but for the most part, the semantics of it are wildly different. So anyway. Predictable latencies. This is one that I absolutely love. Latencies. Latencies drive me crazy for almost everything I've done in my career. So, things where Pony can really help you with latencies. The first and most important one is that there is no stop the world garbage collection. There is a garbage collector in Pony. I happen to love garbage collectors. Almost every single time I've ever manually managed memory in my life, I've started off with it's really nice, and you call malloc a few times, and then it starts getting to be that the overhead of calling malloc is your problem for performance. So you start doing things like allocating larger slabs of memory ahead of time, doling out little bits from a pool, and 3 months later you have a poorly written garbage collector on your hands. So in the end, I'm a big garbage collection fan. There is the garbage collector, like I said, in Pony. Like Erlang, but unlike Akka, it is a per actor heaps. That means that each individual actor has its own heap and will be garbage collected on its own. So if you have 10,000 actors within your system, then you basically effectively have some concurrent garbage collection going on at all time. So this means that you are effectively always doing processing. Unlike a system like the JVM, which has stop the world garbage collection for the standard standard GC algorithms that come with it, that does not happen with Pony, so you'll continue processing the entire time. Additionally, we have a feature we're going to get into more again later called reference capabilities. And reference capabilities allow us to do fun, unsafe things in a very safe fashion. If you look at like Erlang, for example, Erlang, except for in the case of a thing they call binaries, does a copy on pass for when you send a message from one actor to another. This results in memory being copied, and all in all is a slower operation than if you could just pass a pointer from one actor to another. Pony's reference capabilities allow you to do this safely, which means that we can go faster than you would if you didn't have that, and we'll get more into reference capabilities in a minute. Now, one of the really nice things about concurrent garbage collection is that if you're writing a clustered application, concurrent garbage collection or otherwise avoiding stop the world pauses can be a really big win. There's a paper called Trash Day, and I'm going to have a link to it at the end of this, which is about a means by which they improved performance of a Hadoop application by 20% simply by synchronizing the garbage collection phases of all the JVMs that were running in the cluster at one time. They got about, I believe it was a 20% improvement, but I don't really remember. Ori, who I don't really know, he's shaking his head up and down, though. I think 20 sounds right to me. It says it sounds right to you, so we're going to go for that. Effectively, what you really have happening there is if you have a cluster of machines where, say, machine A is feeding to machine B to machine C, if machine B has a garbage collection event, this means that it's going to stop processing, which means that now C, in all likelihood, is not going to have data that's going to be able to process. So rather than just losing one machine for the duration of that garbage collection, you probably lost 2 machines in the effect of that, and this gets worse the more connected and strung out that things are. All right, so data safety. Data safety in Pony is really all about reference capabilities. If you go to the Pony website and start trying to learn about Pony, there's a section which will talk about reference capabilities because reference capabilities are what trip everyone up. Reference capabilities are basically putting into the type system the codification of patterns that I learned a long time ago when I was writing high-performance network servers in C. And these were basically patterns of how do I stop segfaulting my application. When I first started writing stuff in C all the time, I actually originally started in Ada, but I got really mad at it because it wouldn't compile my programs. So I switched to C, which was very kind and would compile my programs, and then they crashed for several weeks. But you know, at the time I was happy. I felt like I had accomplished something by getting it to compile. So there were an awful lot of patterns that I ended up learning, which unfortunately, though, are patterns that I always had to remember to follow. And if I didn't follow those patterns, what would end up happening is that my program would segfault, or I would have weird data races where the data would end up in a condition that was probably not right, but it's kind of hard to tell because it's a highly concurrent application, and you never really know when you have 12, 15, 20 threads running whether it's actually right or not. So basically, what reference capabilities are is you can think of them as type annotations, where previously in a typed language you might say something like this is a string. What you would instead say is something like this is a string ref, or this is a string ISO, or this is a string val. In each of these are tags which says something about how it's safe to use this data. So you have ref, for example. Ref is the standard mutable object that everybody knows and loves. You can do whatever you want to with a ref inside of an individual actor, which means that it'll only be worked on within that one thread. But the compiler will stop you if you try to send that reference to another actor, because it's not safe to access the same mutable set of data across 2 different actors. Now, if I wanted to have some mutable data and I wanted to be able to send it to another actor, that's fine and good. There's ISO for this. And ISO basically says, hey, before I can hand this off to somebody else, before I can send it to somebody else, I have to give up my reference to it. And that's all encoded inside the type system. Then we also have val, which means, hey, this is immutable. It's pretty much safe for me to do whatever I want with it. And tag says, hey, this is an opaque reference to it, so you can send messages to it, but not much else. There's a couple other reference types, but you don't really have to worry about those right now. The big point is that the reference capabilities go ahead and they allow you to get help from the compiler in order to write code which will run fast and run correctly. So early on when I first started using Pony, I think it was like my second or third month. We were basically at the point where we were still evaluating whether we wanted to use it for our product. And I did this thing, this pattern that I'd done probably 1,000 times in other stuff, where I had a couple different threads. In the Pony case, there's a couple different actors, and I had a data structure, and I was like, oh, I need to send that data structure over to the other actor because I need to have another thread have access to it. And the Pony compiler complained. Basically, it said, that's not safe. And I sat there, and I looked at it for like 5-10 minutes, scratching my head, not really understanding what it was telling me or what was going on. And then eventually it dawned on me that this thing, which I'd done numerous times over the course of my career, was actually unsafe in certain scenarios where it could result in a data race problem. It could result in corruption. And it was so unlikely and so hard to possibly reproduce, there would probably be one of those things that would come up every now and then. You'd call it a Heisen bug, file it away in a system, and maybe if you were lucky, you might happen to have somebody like stumble across the case where this would happen, but for the most part, you wouldn't. And for me, this was really my aha moment with Pony. This is when I was like, I love this language. This is going to save me so many headaches because it lets me do unsafe things in a safe way, and in the type system will prove to me that, hey, it's okay to do this. And even more importantly, it will prevent me from, like, if I'm having a day, like, say, yesterday, where I had arrived in Paris and I was a little jet lagged, and it caught like different, like, not particularly good ideas that I had at the moment, but the type system stopped me from doing it. So data safety, big, big win. Now, all of this said, like, I do love Pony, but there are plenty of reasons why not to use Pony right now. So let's talk about some of those. First of all, if concurrency isn't your problem, you probably shouldn't be using Pony for all of the other reasons that have come after this. If you can write your application and it runs perfectly fine in a single-threaded language like Python where you have a GIL, then by all means, do not use Pony. It's the absolute wrong tool for you. Beyond that, Pony is pre-1.0. I released Pony 0.15.0 this morning. I missed the first part of the conference this morning because I spent 2 hours writing release notes. But so there is a lack of API stability. For us at Sendence, this hasn't been a particular problem because we probably created about 80% of the lack of API stability, so before it ever hits the mainline Pony compiler, we've already dealt with it. That said, usually most of the things that break are fairly simple and you can fix them in like 10 to 15 minutes. On the other hand, that lack of API stability can be really worrying for some folks. This can be particularly bad if you want to use third-party libraries because there are almost none. And the folks who did actually write third-party libraries are probably not tracking the latest changes in Pony all that quickly. There's a fellow, Joe, he's on the core team. He has like 3 or 4 open source Pony libraries, and he never updates them to the latest version of Pony until somebody says, hey, Joe, I need this updated. So also a really good reason not to use Pony. Like I said, in general, there are no batteries included. Python likes to talk about how it's batteries included. You want to do JSON parsing? Boom, there you go. There's a library for it. You want to do this. You want to do that. I'll say this in Pony. If you really like writing your own libraries, then Pony is a great language for you right now because you're probably going to have to write almost everything from scratch. However, if you're trying to write a high concurrency, high performance application, then in all likelihood, you probably really don't want to be using a lot of other people's libraries anyway, because they've already made a series of tiny decisions which are probably going to have a large impact on the performance of your application. But if you're trying to stand up a website, trying to stand up a microservice, not the right thing for you. Also, limited native tooling. Debuggers, profilers, IDEs, these are all things that people love. The editor that has the best support for Pony right now is Sublime Text, so we can probably just stop talking about IDEs from there. Debuggers, well, you can use LLDB or GDB. I'm older, I love GDB. I'm in a shrinking set of people who do that. But LLDB and GDB don't actually understand Pony. What we did was we faked it using the dwarf info so that they think it's C++. And if you start using Pony, there's a section on the website which gives you a cheat sheet of how to navigate Pony objects inside of a step debugger like LLDB so that you can inspect your Pony code and your Pony objects when the debugger thinks that they are C++. Now, that said, because it shares the same ABI as C, all of your wonderful Unix tools like strace, dtrace, all of these things that you might use in order to do it, you can debug all of it. You can debug or profile all of your Pony applications with those. So, like I said, is Pony right for you? Well, yes, if you have a hard concurrency problem, possibly. If you aren't reliant on existing libraries, it might be. If you're willing to write almost everything from scratch, again, it might be. So really, takeaways for this are that Pony has a powerful data race-free concurrency type system, which, and a high-performance runtime that can help you solve hard concurrency problems. You might be able to use Pony in production now, but in all likelihood, for most people here, more likely you might just want to play around with it to get some ideas of some cool stuff that a type system can do for you. And go ahead, these are the links if you want to take photos of them real quick to Orca paper, which will teach you more about the Pony garbage collector, which is actually ridiculously cool if you're into garbage collectors, and also the trash day paper. And lastly, these are a few links for stuff. If you're interested in helping out with Pony, we'd love to have more people all the time, particularly folks who love to write documentation. I'm getting really tired of writing documentation. I could use a break for a while, use some help with that. Also, folks who want to do stuff like write high-performance HTTP servers, write high-performance JSON parsers, etc., because we'd love to get more companies and more people using Pony in production. And in the end, we are a volunteer project. We don't have a large corporation like Mozilla or Microsoft or anybody else backing us, so we could certainly use the help and assistance. That's it. Questions?
Thank you.